Hello students, in this video we're just going to do one question. However, this one question involved quite a lot of concepts from the chapter on trigonometry. Right, let's look at questions 8 part I. We're asked to prove that cosecant 2 theta minus cotangent 2 theta equals to tangent theta. So what are the concepts involved here? Yes, first of all, we need to recognize that cosecant theta is actually equals to 1 over sine theta. And how do you remember it? That is, let us take a look at the third letter of the cosecant theta. Right, the third letter of the cosecant theta is the letter S, and S is the first letter of the trigo function sine. So that is equals to 1 over sine theta. Right, the second concept will involve cotangent theta. And if you look at the third letter, it is a letter T. So T is the first letter of the trigo function tangent. So it's 1 over tangent theta. And what other concepts is involved here? Yes, we need to know how to express tangent theta as sine theta over cosine theta. And if you look at these questions, what other concepts do you think you need to have? Yes, of course, if sine theta over cos theta is equals to tangent theta, then cos theta over sine theta will be equals to cotangent theta. Because cotangent theta is 1 over tangent theta. And if we just reverse, flip this to get cos theta over sine theta, flip tangent theta, because tangent theta is tangent theta over 1. You flip it, you get 1 over tangent theta. And to 1 over tangent theta is equals to cotangent theta. Alright, so what are the concepts that you need to know? Yes, we need to know that cosine theta can be expressed as 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta, or cos squared theta minus sine squared theta. So in order to do this chapter well, right, it's best to memorize all these formulas. This is like the ingredients in your cooking. You need to have all these ingredients so that you can what do you call that, without a fantastic dish, right? So how are we going to apply these concepts? Yes, let's start proving from the left hand side. And why do you start proving from the left hand side? Because you have more terms to work on. The left hand side comprises of 2 terms, that is a cosecant 2 theta and cotangent 2 theta. So there are more things to work on. So we start on the side that you have more to work on. Alright, so let's rewrite cosecant 2 theta as 1 over sine theta, sine 2 theta, and your cotangent 2 theta as cos 2 theta over sine 2 theta. And you will see that we have a common LCM, which is sine 2 theta. Oh no, it's not LCM. We have a common denominator, which is sine 2 theta. So we can just combine them into one single fraction. Right. So what we need to do now is we need to make a decision. And that decision is we need to get rid of we need to rewrite cosine theta. So there are 3 options here. Right, you can replace your cosine 2 theta with 2 cos squared theta minus 1, or 1 minus 2 sine squared theta, or the last one. So supposing I replace my cos 2 theta with 2 cos squared theta minus 1, make sure you bracket it. And if you simplify it, you have to bracket it. If you don't bracket it, then you won't get plus 1. And you see that, okay, I'm just going to leave my denominator untouched first. You see that if I simplify it further, I have 2 minus 2 cos squared theta. And that doesn't help me. Because what I want to have is, when I substitute my cos 2 theta, it will make the term simpler. That means right now I have 2 terms. I have 1 and then have cos 2 theta. There are two terms there. So what I want to do is I want to make it such that maybe it become one term, you know. So substituting cos 2 theta with 2 cos squared theta minus 1 doesn't work at all. Alright, so we don't use that. Then how about the last one? If I were to substitute the last one, do you think it will work? Well, that will give you 1 minus cos squared theta plus sine squared theta. And again, that's not very helpful. Alright, so we're not going to do that. Right, so what we're going to do then is to replace our cos 2 theta with 1 minus 2 sine squared theta. And again, make sure you bracket it. This is very important. So when you bracket it and you simplify it, yes, you will get 1 minus 1 plus 2 sine squared theta over 2. Oh, okay. And another thing is that sine 2 theta, we can write it as 2 sine theta cos theta. Why do I want to write it that way? Because after simplifying your numerator, you will see that the answer that you will get at the numerator, it's in terms of theta, not 2 theta plus theta. So that gives you an idea that I have to express sine 2 theta as 2 sine theta cos theta. Okay, which is what I have here. Alright, so simplify it further. I would have 1 minus 1 give you 0. 0 plus 2 sine squared theta will give you 2 sine squared theta over 2 sine theta cos theta, and 2 and 2 divide each other gives you 1, and sine squared theta divided by sine theta will give you sine theta. Ayo. Okay, sorry, need to erase it. Oh, I did have the but I think the sequencing of the animation is incorrect. Okay, and so that will give us sine theta over cos theta. And using this concept here, sine theta over cos theta can be expressed as tangent theta. That's how we proved tangent theta equals the right hand side. And that's how we do part A, part I. Right, let's look at A part 2. And A part 2, we are asked to solve a trigo equations. And the important word to take note of is the word hence. Hence means you have to make use of the answer that you obtained in A part I. And what is it that we have done in A part I? Yes, we have proved some trigo equations. And what is it that we proved? Yes, we proved that cosecant 2 theta minus cotangent 2 theta is equals to tangent theta. It's actually identity. Alright, look very carefully at the angle here. You will see that it's some kind of a connection such that this angle here, theta, is half of this angle here, and this, that means 2 theta times half will gives you theta. So therefore, cosecant 4 theta minus cotangent 4 theta can be expressed as tangent 2 theta. Because half of 4 theta will gives you 2 theta. Right, so what we are solving here is tangent 2 theta equals to negative square root 3. And if you look at this square root 3, it will remind you of it will remind you of the special angle concept. Right. And one way to remember the special angle concepts, what are the angles that are considered special? Yes, angles such as 30 degrees, 60 degrees, and 45 degrees. So I've done a video on how you can actually memorize all the special angle. But one favorite way that I usually like to use is just to use the trigo ratio. I always remember sine 30 as half, because if you use your calculator, sine 30 will give you a rational number. And I can find the adjacent side using Pythagoras theorem. That will be 2 squared minus 1 squared. That gives you 3, and you need to square root it. And if this angle is 30 degrees, then the other angle, the complementary angle, will be 60. And from there, I can find tangent 60, because this will be my opposite side. This will be my adjacent side. So tangent 60 will be square root 3. Right. Okay. But to solve a trigo equations, I don't know whether you remember, we have to find this thing called the reference angle or the basic angle, which is just an acute angle that's between 0 and 90 degrees. Hence, and if it's an acute angle, the trigo ratio of acute angle will be a positive value. So therefore, even though we are solving an equation that is equals to negative square root 3, we will just ignore the negative sign when you find reference angle. Okay, you ignore this one here. Right, you see that I'm finding tangent inverse square root 3. And from this diagram, tangent inverse square root 3 is 60 degrees. Because tangent 60 gives you square root 3. Tangent 60 gives you square root 3. Right, so therefore tangent inverse square root 3 will give you 60. And because you're supposed to express your answer in terms of radian, this is very important. So 60 degrees, you can just convert it into radian, and that is taking pi divided by 3. How do you do that? Because 180 degrees is equals to pi. So 1 degree is pi over 180, and 60 degrees will be pi over 180 times 60. So basically, you just take 60 divided by 180 times pi, and that gives you 1/3 pi, which gives you pi over 3. Okay? Alright. Then the next important thing is we need to identify where the angle is coming from. That means which quadrants we're interested in. And that will involve the concepts of your ASTC. And that involves going back to the original equation. Your original equation. Let me erase all this thing. It's very confusing. The original equations, right, is such that you want to find the angle where it gives you a negative value. The trigo ratio of the angle will give you a negative value. And for tangents to have a negative value, then the angle will have to come from the second and the fourth quadrants. Alright, so to find the second quadrant, we will just take pi minus the basic angle. And to find the fourth quadrant is 2 pi minus the reference angle. And because we're finding the answer for theta, right, it has to be between 0 and pi. We have to find the new range for 2 theta. And the new range for 2 theta will be between 0 to 2 pi, which is 1 cycle. So we don't have to continue anymore. We just need to find the answer from the second and the fourth quadrant. and then we divide your answer by 2 to find theta. Right, let's look at part B of this questions. You're given the angle A and B such that sine bracket A plus 45 degrees is equals to 2 square root 2 times cosine A, and then 4 secant squared B plus 5 equals 12 tangent B, second equation. And finally, you're asked to find the exact value. Right, so when you're faced with this sort of questions, what do you think, how do you think you should approach the questions? Yes, like what I've mentioned earlier on, to do trigo, to do this chapter well, you just have to remember all the formulas. You just need to have all the formulas right at your fingertip, so that when you see something like this, you know that you have to use the addition formula, which is, yes, sine bracket A plus B will give you sine A cos B plus cos A sine B. And then when you're given something like this, which formula do you think you should be using? Correct, the trigo identity. The three trigo identities, the sine squared A plus cos squared A equals to 1. The second one is 1 plus tangent squared A equals to secant squared A. The third one is 1 plus cotangent squared A equals to cosecant squared A. So all this formula must be at your fingertips, so that at one look you know that, yes, I need to use that, right? Okay, so let's do it now. And of course, the special angle. How do you know I need to use a special angle? Because the three special angles that I've mentioned earlier on are 30 degrees, 45, and 60. And if you look at what you're given 45 degrees there. So that gives you the idea that this questions also involve the concepts of special angle. And if you recall what I've said earlier, there are many ways of remembering your special angle, but I usually like to use the trigo ratio, right? Like for example, I will just remember sine 30 is half, tangent 45 is 1. You don't really have to remember, you just use a calculator. You just use the one that gives you a rational number. So sine 30 will be a rational number, tangent 45 is 1. And with just these two, you can actually go about finding the remaining value of for your trigo ratio of the special angle. Okay, so here we are. Okay, 45 degrees, tangent 45, it's opposite over hypo, which is 1 over 1. And then use Pythagoras theorem to find your hypo, which is square root 2. And if this is 45, the other guy is also 45. All right, so we're going to use the addition formula to expand sine bracket A plus 45. All right, and then I'm going to replace cosine 45 as 1 over square root 2. And sine 45 also happen to be 1 over square root 2. Okay, the next step is I'm just going to multiply by square root 2 throughout to get rid of my 1 over square root 2. Right, so I just basically multiply by square root 2 here, times square root 2, and also times square root 2. So this will give me 1, and 1 times sine A will be sine A. Right, and square root 2 times square root 2 will give me 2, and 2 times 2 will give me 4. All right, so here comes the part that is a bit tricky, but it's not difficult, because in the earlier slide, we have gone through this concept where sine A over cos A can be expressed as tangent A. So therefore, I'm just going to divide by cosine A on both sides. Okay, divide by cosine A on both sides, and I will have tangent A equals to 3. Alright, so I found the values for tangent A, and I'm not done yet because I still need to know the value for tangent B, right? And where do you think I can get the value? Yes, of course, I can only get it from the second equation. And the second equation is the one that I need to use this identity to substitute my my God, secant, my secant squared B with 1 plus tangent squared B. Right, and simplify it, and you will get a quadratic equations in terms of tangent B. And please don't just write down the answer. I know you can use your calculator to find the roots. The calculator will give you like x equals to 3 over 2. All right, don't write down this because in the report that I've seen, you're actually supposed to explain how you get tangent B equals to 3 over 2. So therefore, you need to work backwards to form your two linear factors. Okay, from your tangent B equals to 3 over 2, you need to work backwards to get your two linear factors, right, which is 2 tangent B minus 3 times 2 tangent B minus 3. Okay, you need to show this steps. All right, very important. You need to show this step. All right, and then yeah, 2 tangent B minus 3 times another 2 tangent B minus 3 gives you bracket 2 tangent B minus 3 squared. And of course, when you square root both sides, this is what you get. And therefore, tangent B is equal to 3 over 2. All right, so with these two values, we can now substitute into your tangent bracket A minus B. Okay, so from the earlier part, we found tangent A to be equal to 3, tangent B is equal to 3 over 2. Right, so if you have remembered your formula correctly, you will know that you need to apply the formula to expand this. But if you don't have all these formulas at your fingertips, what some of you may do is went on to find the angle A, went on to find the angle B, equals to some angle, and substitute inside there, and then you get everything wrong. Okay, so that's the reason why that remembering the having the formulas at your fingertips is very important. All right, so what is the formula for tangent bracket A minus B? Yes, that's tangent A minus tangent B over 1 plus tangent A tangent B. So now we can substitute the values for tangent A to be 3, tangent B to be 3 over 2, and then so on and so forth. Use a calculator to work this out, and you get 3 over 11. All right, so yeah, right, so that ends the video. So even though it's just one question, you see that it involves really some solving skills that you need. And the important thing is that you really have to memorize all the formulas, so that you know when and how you can actually use this formula, right?